Okay, so a little bit of final review here. I'm going to start with this first one, graph and shade the linear inequality. So this is what's called standard form, when x and y are on the same side of the equation. And in standard form, to graph the line, you need to find what's called the x-intercept and the y-intercept. We find the x-intercept by essentially getting rid of the y. So I'm going to plug a 0 in for the y. I'm also going to change the inequality to an equal to sign because I just want to plot a point, so I don't really need that inequality. And what happens here is I get 4x minus 0 equals 24. Well, 4x minus 0 is just 4x. And if I divide both sides by 4, I end up with an x-intercept of 6. So what that means on the x-axis, which is this one right here, on the x-axis, I can make a point at 6. So that's an x-intercept of 6. I'm going to do the same thing with the y-intercept. So for the y-intercept, I'm going to plug 0 in for x, and I'm going to solve for y. So I end up with 0 minus 3y equals 24, which is really just a minus 3y equals 24. And if I divide both sides by negative 3, I end up with y equals negative 8. So on the y-axis, which is the up and down axis, I'm going to make a point at negative 8. And since it only takes 2 points to make a line, now I can connect those 2 points, the x-intercept and the y-intercept. And I'm going to connect them with a solid line, and the reason that I'm doing a solid line rather than a dotted line is because this inequality symbol is what's called inclusive. So it includes all of the points on the line. So because of that symbol with the equal to line underneath, I know I'm going to do a solid line. At this point, I'm going to either shade above my line or below my line. And that all comes down to my test point. And my test point is always 0, 0. It's just the easiest point to test. So what I'm going to do is I'm going to test 0, 0. By plugging 0 in for x and 0 in for y in this inequality. So I get 0 minus 0 is less than or equal to 24, or 0 is less than or equal to 24. 0 is less than or equal to 24, so that tells me that the point where 0, 0 is, that's true, which means the other side of the line is false. You want to shade the true region. So I'm going to take a highlighter here and I'm going to shade all of the stuff above the line because this is the region that's true. This means that everything on this side of the line is a solution to this inequality. Okay, we're going to do something similar with the next one, except now instead of one inequality, we have 2. So I'm going to first plot this line in red. This is called slope-intercept form because unlike this first one where x and y are on different sides of the equation, the same side of the equation, in this one they're on different sides. So what we need to plot here is the y-intercept and the slope. The y-intercept I can tell right from the problem. The y-intercept is the one that doesn't have the x with it. So we have a 1/2 x and then that minus 4 is on its own. The minus 4 is the y-intercept. And I'm going to plot that on the y-axis, which is the up and down axis. So at negative 4. And then the slope is 1/2. So what that means is I'm going to go up 1 and right 2. I'm always going to go to the right. Never make a point on the left-hand side of your original y-intercept. So because the slope's positive, I'm going to go up 1 and I'm going to go over 2. And that's where I'll make my next point. I can keep doing that pattern, up 1, over 2. Or if you're really good with a ruler, you can just up 1 over 2. You can just connect your points like that. You only need 2 points to make a line. So I am going to connect these points. And again, because this is a solid line, because this has a line underneath it, it's inclusive, I'm going to do a solid line when I connect my points. So that's what I get when I plot the first line. I'm actually going to hold off on the shading for right now, and I'm going to graph the next one. X equals is a vertical line. Because it's only x by itself, there's no y. So this is going to be like an up and down line at the x value of 2. So this is the x-axis. So I'm going to make a point at 2, and I'm just going to go up and down. You can do as many points or as few as 2 as you want. Now, because this does not have a line with it, I am going to connect this with a dotted line. I'm going to dash it when I use my ruler. So you'll see I'm not going straight through. I'm just dotting this line as I go. Right, so now that I have my 2 lines, what I see is that those 2 lines created 4 regions. I've got this region over here, this one, and this one. And only one of those 4 regions is going to get my highlighter. So what I'm going to do is I'm going to test my 0, 0 point. And I'm going to see what happens for each of these. So for this inequality, I'm going to replace 0 with my x and y. So I get 1/2 times 0 minus 4. 0 is greater than or equal to -4. That's true. So if 0, 0 works for the red line, okay, so this is the line I'm focusing in on. This point is true. And I'm going to shade with the true. So I technically would shade everything above the line, which is going to put me in regions 1 or 2. So I'm just going to make a note that my answer is either region 1 or 2. Then what I'm going to do is I'm going to test the other, and I get 0 is less than 2. And that's true as well. So if I'm focusing in on this line with respect to this point, and that point's true, I would shade with the true, which is going to have me shading regions 1 and 4. And what these 2 things have in common is region 1. So that tells me that region 1 is the solution to this system. So I'm shading everything in region 1. All right, so that is a review of what we call linear programming, graphing inequalities, and shading. If you flip to the back, we have a little bit of geometry review here. So you might remember or have PTSD from putting a point in the middle and making our pizza, and then thinking about if I ate this slice here and this slice here, how much of the pizza was eaten. And it's half the pizza. So we think about a full 360. A full circle is 360. So half a circle is called a 180. So this relationship is what we call a linear pair. We also call it supplementary, which means that the 2 angles added together equal 180 degrees. So I'm going to take angle 1 plus angle 2, and I'm going to set it equal to 180. From here, what I'm going to do is I'm going to combine my like terms. So 6x plus 10x is 16x, and 19 minus 15 is positive 4. And now I'm just going to work on doing inverse operations to solve this equation for x. And 176 divided by 16 is 11. So x equals 11. It doesn't tell you to solve for the specific angles, but if it did, I could plug 11 in here and 11 in here and calculate what I get for each of those. what I see here is I've got a triangle, and I know that three angles inside of a triangle equal 180. The problem is this angle here is not inside of the triangle. So I want to focus in first on that angle. So think about if you were to make your pizza. This 150 and this inside slice make up half the circle. So together they create that 180-degree relationship. So this angle here is going to be 180 degrees minus 150 degrees. So that together they create a 180-degree linear pair relationship like we had in that previous problem. So I know that this angle is 30 degrees. Now I can focus in on the three angles inside of the triangle. Together those add up to 180 degrees. So I have my 2x plus 12 plus 3x minus 32 plus 30 all together equal 180 degrees. Now what I'm going to do is I'm going to combine my like terms. So 2x plus 3x is 5x. 12 minus 32 plus 30 is positive 10. And now what I'm going to do is inverse operations to get that x alone. And 170 divided by 5 is 35. The problem is it says solve for angle B. So to solve for angle B, what I need to do is I need to take this equation. Let me give myself a little more room. I need to take this equation where angle B is, and I need to plug the 34 in for x. So I'm doing 3 times 34, which is 102, minus 32, which is 70 degrees. So the answer for angle B is 70 degrees. So there was a lot to that problem. We had to use exterior angles to work our way into the triangle. We had to use the sum of three angles inside of a triangle to find x, and then we had to plug that in to find that angle B. Okay, so that sums up our geometry and linear programming review. I hope that helped.